All right, guys, so we're in a new chapter starting today. We're doing notes 7-1, scatter plots and lines of best fit. Let's start off with an example and see how we can work these. A local football team has gained the following yardage in its first 7 days. It says graph the data. Now I went ahead and put my labels on here. I'm saying that my game is going to be my X values, my yards is going to be my Y values. And I went ahead and came over here, I labeled my axes. My X-axis is game, my Y-axis is yards, and I went ahead and filled out a window that'll help me see the whole graph. So it looked like my X values went from 1 to 7, so I labeled them 1 through 10 on the X-axis. My yardage, it looks like my lowest one was 225 and my highest was 350, so I started at 200 and worked my way up by 25 to 400. Now all I'm going to do, guys, is plot the points. I'm going to pause for just a second, so you guys need to go ahead and plot those points. All right, guys, so I went ahead and plotted my points, and when I look at it, it doesn't look like there's like a straight line that I could connect all of them with. It's fluctuating quite a bit. So what we call this kind of graph is a scatter plot. Now I'm going to go ahead and I have to erase this and go down to the next part, but you should have it all graphed. Let's read the next paragraph. This is a scatter plot. Scatter plots are an excellent way to model real-life data to observe patterns and trends. In real life, guys, everything is not perfect like some of the problems we see in here. Sometimes it just kind of moves around a little bit. So what we're going to do here is try to see if we can identify any sort of pattern in that above data. And it says, if so, what? Well, I think I can see a pattern. I don't know if you can, but I'm going to say yes, there is. And if I look at my graph, it looks like everything is getting lower. Except for game 2, it got lower every time. So I'm going to say it seems to be decreasing. Sorry about that. Seems to be decreasing. Sorry, I don't know what's wrong with pen. Decreasing. There we go. Now, that's really all I can tell from her right now. And it says here at the bottom, kind of like what I just said, real-world data does not always fit into a nice straight line. Often, a line of best fit or a trend line must be found to make predictions. This line is drawn so that the points are evenly distributed above and below the line and seem to cluster around the line. So it says, draw a line of best fit on the data above. Now I'm going to go back up to that graph and I'll draw my line of best fit. So I'm back up at my graph now, and it's kind of tricky to draw these, but you're just going to kind of draw a line that goes right in between all of your points. So I'm going to start kind of right here and just draw a line that kind of splits those points down the middle. Now it's not going to be perfect, but you just have to do your best. Like if I were to look at those points, I would think, okay, maybe that line is kind of the average of all those. Now the next thing at the top of the next page, we need to talk about positive, negative, or no correlation based on the slope of a line. And something you need to remember to get these right is that if we are going up and to the right, we are a positive slope. If we're going down and to the left or to the right, we're a negative slope. So let's look at these. The first one, it looks like if I drew a line, it would kind of go like this, and all those points are kind of clustered together around that line. So that looks like it's going up and to the right. That is a positive correlation. The next one also looks like I could draw a line through it, maybe about right here. But once I draw my line, it's going down and to the right, making it a negative correlation. Now, if I look at the last one, I could draw tons of lines. Maybe that one, maybe that one. It could be straight across like this. I really don't know. So since it doesn't look like it's positive or negative, this is no correlation. So that's a pretty easy thing to do, guys. Let's look back at our example from number 1. I want you to write down what type of correlation did the data example have. If we look back at it, it looked like it was going down and to the right. It had a negative correlation. So not a hard concept if you remember what's positive and negative when you're talking about slope. So let's look at an example. It says, Old Faithful is a geyser in Yellowstone National Park. For more than 100 years, Old Faithful has erupted every day at intervals of less than 2 hours. The date in the table may suggest that the time between eruptions may be related to the length of the previous eruption. So what we need to do is label our axes and find a scale to use, and let's plot our points. So I'll give you just a second to do that. So I went ahead and plotted all my points. I labeled my axes. It looks like my x values are going to be the length of the eruption. It looks like my y-axis is going to be the time until the next eruption. The length of times they gave me the x values varied from 2 to 5, going every 0.5 seconds. So I started at 2 and went up 0.5 seconds every time. The time until the next eruption looks like it varied from about 57 up to about 92. So I started at 55, went up by 5s. All I did was plotted my points. Now it says draw the trend line or the line of best fit. So I'm going to start kind of at the bottom here. I'm going to just try to sketch my line as best I can that goes through those points. Maybe something like this. So we've got our line of best fit. And of course yours may be a little bit different. Mine maybe it curves. Like maybe, oh, lost a point there. Let's see, at 5 we were at 92. So about right there. Maybe it looks more like this. It's kind of varies a little bit. Just do your best. So we graphed it, we labeled our axes, we've got our line of best fit. Let's go ahead and go to the next page. So I've got some questions to answer about this last little bit. And the first one says, what type of correlation appears to exist? Well, just a second ago we talked about positive and negative slope. When we drew our line, it was going up and to the right, so that means it has a positive correlation. Positive correlation. It says, what's the independent variable? Well, if you remember, guys, the x values are the independent variables. The y values are the dependent variables. Y depends on what x is. The time until the next eruption depends on the length of the eruption. So I'm going to say that our x value, so we remember, is the length of the eruption. The main thing you want to remember is the x is the independent variable. Now we need to talk about the dependent variable. Well, that's our y values. And if I look at my table, my y values are the time until the next eruption. Time until next eruption. So those are not very hard questions to answer. As long as you look back at your table, know that x is independent, y is dependent. Then it just says name 2 points on the table. Well, that's easy. It gave us several. I'm just going to use 2.5 and 62. And then on the other one, I'm going to use 3.5 and 75. But again, that's not really super important which 2 points you pick. What matters is that you pick them correctly. Okay, don't write them down wrong. I almost wrote 7.5. You don't want to do that. So the next thing it says, find the slope of that line. Well, I can do that. I know I've got an x1 and a y1, an x2 and a y2. So I can throw it into my slope equation. Remember, m equals y2 minus y1 over x2 minus x1. So let's plug those in and see what happens. So I have m equals, well, if I look back at my point, all right, guys, so the next page just has a few questions on it. It says, what type of correlation appears to exist? Well, it was going up and to the right, so that was like a positive slope, so that was a positive correlation. It says, what's the independent variable? Well, independent variables are the x variables. So if we look at our x column, it looks like it was the length of the eruption. Dependent variables are the y variables. If we look at my table again, my y's are the time until the next eruption. The next question, and remember guys, independent's always x, dependent's always y. Keep that in your mind. The next one said name 2 points on the line, so I picked 2 points. I picked them kind of at random. You could pick any two. I picked 2.5 and 62 and 3.5 and 75. But the next question wants me to use those 2 points to find the slope. So I'm going to label 2.5 and 62 x1, y1. 3.5 and 75 x2, y2. Then all I did, guys, is I plug them into my slope equation, and I find out that my slope equals 13. Now, that might not be the slope for every particular piece of that line, but for these 2 points and maybe for a line of best fit, that is our slope. Now, we just found out that our slope is 13, and they gave us a couple of points that we could use. We're going to use 2.5 and 62. And we're going to plug this into our point slope equation to get an equation of the line. Remember, y minus y1 equals your slope times x minus x1. And guys, we have x1 and y1 right here. So I'm going to have y minus y1, y minus 62, equals our slope 13 times x minus x1, which is 2.5. Now we need to clean that up a little bit. I still have y minus 62 equals 13 times x is 13x. 13 times negative 2.5 is minus 32.5. We're almost done. We have one more step. I need y by itself, so I'm going to add 62 to both sides. I'm going to come over here to the right. So when I finish, I get y equals 13x plus 29.5. So now, guys, I have an equation, sort of like my line of best fit, that I can use to kind of predict a few things with. And that's what the last two questions ask. It says, what would be the best prediction of the time until the next eruption if the length of the eruption is 2.3 minutes? Now, we just found out the length of the eruption is the independent variable, or x. So I'm just going to plug that in for x. So I have y equals my 13. My x is 2.3. And then I add the 29.5. 29.5. And now, guys, it's just a simple calculator application. If I put it in, it says it equals 59.4. So that's going to be my y variable. That's the time until the next eruption. Now, the next one asks it just a little bit differently. It says, what would be the best prediction of the length of the eruption if the time until the next eruption is 70? Now, time until the next eruption is our y value. So this time I'm going to plug in 70 for y, and that equals 13x plus 29.5. So we can subtract 29.5 from both sides. When I do that, I'm going to come over here to the right. I get 40.5 equals 13x. Man, this is messing up on me. Equals 13x. Now, guys, to solve for x, I divide both sides by 13, and I get x equals 3.12. And that is a 40.5 right here, not a 46. Sorry if that confused you. So, guys, that's not a very big deal. It's kind of similar to what we've been doing. I hope this helps you out. And if you have any more questions, just let me know.